Alrighty, here we go. Law of sines. Now, the law of sines is kind of a nice, easy law to deal with. Okay. Now, first thing that we're going to do is we're going to take a look at some of these cases of triangles on here. So, I mean, it's pretty easy that we can identify congruent triangles by, you know, angle, side angle, or side angle, angle. Okay. So we can do that. We can do that. Then we've got side, side angle. Okay. That would be a possibility if I know two sides and one angle, right? Then I've got side angle side, and of course side, side, side. Now this is to solve an oblique triangle. Okay. So don't confuse them with the wonderful little things that we had learned back in geometry. Now this right here, make sure that you have this information available to you. I'll give you a few moments to take care of that. The law of sines is a wonderful thing, so make sure that you have it. So, how do we deal with this? Let's try this. This one. So I need to solve a triangle that's set up like this. So I got A, I've got B, and I've got C, correct? Angle A is how many degrees? 40. B is 60 degrees. I don't know what C is, but angle measure of A is 4. Okay. So this tells me that if I have the sine of 40 degrees over 4 should be equal to the sine of 60 degrees over B. Okay. That's one of them, right? Now, we know that these two add up to 100 degrees, so that means that C down here is 80. Would you agree with that? So that also means that I can use that the sine of 40 degrees over 4 would be equal to the sine of 80 degrees over C. Now, I'll caution you here. You'll notice that I used the sine of 40 in both of these. That was information that I was given. More often than not, when you go through and do this ratio and solve for B and solve for C, you are going to get something that is going to be just a wee bit uglier than a nice, easy number. So, grab calculator. Make sure that we are in degrees. So, I would take the sine of 60, enter, multiply that by 4, enter, divide that by the sine of 40. Okay. See what I mean by a not so nice number? So we could basically say that we're looking at 5.4. So B is equal to 5.4. What about C? Do the same thing all over again. Clear that out. So I would hit the sine of 80, enter, multiply it by 4, enter, divide that by the sine of 40, close it, enter, and I get 6.1. So C is equal to 6.1. So if I go back and take a look at what they had, they took it out to 2 decimal places. Seem reasonable? It's not that bad of a deal. Okay. Let's try this one. So I've got another triangle here. 35, 15. Now sometimes it does kind of help to make sure that you have, so if I want to call this one A and I want to call this one B, that means that angle C is going to be kind of on the larger side. Would that make sense? So we've got a 35 down here. We've got this as 15 degrees here, and C is going to be 5. Well, how many degrees is C going to be? Well, 15 and 30 add up to a nice 50, right? So that means that C is 130 degrees. So now do I have enough information to go through and set up my ratios? So if I want to find B, I could end up taking the sine of 130 degrees over 5 is going to be equal to, the sine of 15 degrees, supposed to be a 30 in there, over B. Likewise, sine of 130 degrees over 5 is going to be equal to the sine of 35 degrees over A. And again, this is just simple calculations once we're to this point. It's setting it up and making sure that you've got the bits and pieces all put into place. So let's try this one now. Side-side angle. Now there's a reason why you were told back in geometry that you cannot use side-side angle. Or another way of remembering it is if you reverse the orders of the letters, it's not something you should really write down in your assignment, is it? O. So, see, part of the problem is here, let's see. Comes right down to here. There's a possibility of two triangles. So, depending upon which way this goes, so if I've got an angle and I'm told this angle down here is A, okay, given that value, and then I am told that, we got a side here and a side here. Which way do you go? Do you make it go this way or do you make it go that way? I don't know. Because we're not told what either angle B is or what angle C is, we cannot make that determination. So it turns out to be an ambiguous case. Now, one triangle is going to happen if and only if A is greater than or equal to B. So if I know that this side of A is larger than B, the only way for me to draw that triangle out is to go this way with it. Okay. Or if it's equal to it, then I would have an isosceles. Okay. But if it seems to be shorter, I could draw it, over to here. I could draw it here. I could draw it there. I mean, there's a lot of different places I can go with that thing. So if A is larger than B, I only get one triangle. So let's take a look at what we got. So when we're creating our triangles, we need to make sure that we're a little bit more open about these things and identify what's going on. So I've got an angle here that's 40 degrees. So here's an angle that's basically going to be called A, and that's approximately 40 degrees. Does that make sense? Now, B has a distance of 2 units. A is larger than that, so I can't have it go this way, because if I go and draw a line that is longer, then it wouldn't necessarily make a triangle, would it? So that means that this thing is going to have to go out here someplace in order to fit. So finish that off. We know that B's distance or A's distance is 3. So now, do I have enough information here to go and figure this out? Well, as long as I've got an angle and I know the side opposite it, I'm okay here. Because now I can set this up as sine of 40 degrees over 3 is going to be equal to the sine of, okay, this is side B, so this is going to be angle B, right? This is going to be C, because this is going to be side C down here. That makes sense? So that means it's the sine of B degrees over 2. So I've got basically the same setup here, but my calculation is going to be a little bit different this time. So what I am going to do is still multiply on the diagonal and divide by the other number. So delete this. So it's going to be the sine of 40 degrees, enter, multiplied by 2, enter, divided by 3, enter. But now I have to get back to the angle measure for the sine of B. So what I am going to do is I am going to go second, inverse sine, and then I am going to press second, and right above the negative sign down here is A and S, so it'll bring back the previous answer and put it in there. And so now I've got my degree measure. So my degree measure is approximately, for B, 25.37 degrees. Now, do I have the information to go and figure out what angle C is? So I could go back to the calculator and let's see. I could take 180 minus 40 minus the last answer, and I turn out to be 114 degrees, 0.63. 114.63. Now, do you start seeing how things can get a little strange here and get off? When we were talking about the unit circle and we were trying to use exact values as much as we possibly can I get exact values for anything that I'm working with here? I'm always rounding, okay? And so that's going to tend to get things off a little. But I've got my sine of 40 degrees again over 3 is going to be equal to the sine of 114.63 divided by whatever that side is going to be, right? So now, mind you, I've been keeping a lot of this stuff in the calculator. I've got an answer here. So rather than trying to always put it back in again and type it, you can utilize the calculator's ability to deal with the last answer. So I can take the sine of last answer, multiply that by 3, divide that by the sine of 40 degrees, and I end up with 4.24. So this side down here could be at 4.24. Now, does this seem reasonable? Is the largest side opposite the largest angle? And we've got that ratio established, so far so good. So that is one of the concerns that you need to make sure that you have in mind when you're working through these things. Okay. Now, there is a possibility that you will have to use 2 of these. So let's take a look at this triangle here. So I want to solve this triangle here. And let's see. We got paste. So, is A larger than B? No. So in this particular instance, we are going to have to consider that there are going to be more than one triangle. So there's a possibility that we could end up getting one, let's see, from here to here. I don't like arrows on that. And from here down to here. Those are now odds. Should they be exactly the same? Probably. So sometimes what I can do is adjust so that looks about right. Get that. So there's my possible triangle. And let's see, this is going to be angle A down here, and that's going to be 35 degrees. Now, the side could either be 6 here or it could be 6 here. We don't know which one it could be. This side B here is going to be 8, so that means angle B is down here, or B is over here. That also means that we've got a side C1, we got a side C2, that would be the whole thing going across, and we've got to think about angle C1 and angle C2. Those are always the possibilities on this thing. So it gives us a lot more to work with, but we need to make sure that we take into account both of these. Does that make sense? Setting it up like that? So when you draw it out, I mean, you can still go through and work it out. The value here is going to be one of two things, right? So that means that I'm going to have this set up and I'm going to have the sine of 35 degrees over 6 is going to be equal to, we need angle B here, so sine of B degrees over 8. Now, hopefully you're starting to look at this and say, well, hold it a sec. How can the calculator give me another possible value out of this? Because we're going to be taking the sine of 35 degrees, multiplying it by 8, dividing it by 6, second inverse sine of that answer, and I end up with 49.89 degrees. So that means that this one here would be 49.89 degrees. Has to be that way because it's a acute angle. Now my question for you is, going back to the unit circle, when we do inverse sine, where does it return? Which quadrants does it return in? Suppose it would be nice if you brought up, okay, oh, I don't have, yeah, quadrants 1 and 4, so it returns it here. So X has to be where? If I'm returning this and it's not negative, that means it's up here in the first quadrant, correct? What does X measure? Is X, or I should say, is the sine, is that X or Y? So that means that I can get the same value over here, and I can get the same value over here. Okay. So how would I find what's over here? Well, whatever the degree measure here is going to be added to 0, bring it up here. If I want to find where it is the same over here, so square, half over here, half over here, I take 180 minus that degree. So when I am looking at this, you'll notice that they go and take 180 and subtract things away. Okay, 49.9, 180 minus that. So that means that the other possible value for B would be 180 degrees minus our 49.89. So that would give us the other possibility of 130 degrees, 0.11. Now that I have that information, I can go through and find out the missing values for C1 and C2. That's easy enough. Just subtract, add these two up, subtract from 180, gives us the angles up there. Then we can go and set the ratios up again and see what we've got. So be aware of when you're finding this, you're going to be getting the acute angle. Then to find the obtuse one, subtract that value from 180 degrees. So, and sometimes when you set this up, you're going to find that there is no possible solution. The reason why is you're going to get a value over here that's greater than 1. And you can't do an inverse sine on anything that's bigger than 1 because inverse sine only lives between 1 and negative 1. So, finding the height of a mountain. Doesn't this look like fun? Let's walk through one of these possibilities. Okay, so here we go. They want to measure the height of a mountain. A surveyor takes two sightings from the peak at a distance 900 meters apart on a direct line to the mountain. So, distance here was 900 meters. I don't know how far it is from here over to here. I just know that distance is. And he's 2 meters tall, or what the transom that he would have been using, 2 meters off the ground. So, what we need to do is find out what these triangles are going to be. Now, what do I know? Well, I know that this triangle here, that's 900 meters, correct? I know what this is here. Do I know what these angles are going to be? Well, I know exactly what this angle down over here is going to be, correct? Because this is 47 degrees. These two must add up to this, so this has to be 12 degrees up here, correct? That makes sense? By the way, what would this angle down here be? Well, isn't this supplementary here? So one should just simply be 180, 180 minus 47. So that means this angle down here is going to be 133 degrees. So do I have enough information now to set things up? To find out all the other information about this triangle here. Well, let's see, I could take the sine of 12 degrees over 900, right? Wouldn't that be equal to the sine of, let's see, 35 degrees? And we'll call this one A, we can call this one B down here, we'll call this one C up there. And that would be over A. Because if I knew that distance, that would really be helpful, wouldn't it? Or wouldn't it? Would it be helpful? Because then after a while, could I set up the other equation based off over here of the sine of 90 degrees over whatever that A was? Wouldn't that be equal to, wouldn't that be equal to the sine of 47 degrees over the height? Would that work? And then once I know what the height is, I just have to add 2 meters to it in order to figure out what the height of the mountain was. So let's see if that setup actually makes sense to us and we come up with what we want. So that means I would need the sine of 35 degrees multiplied by 900 divided by the sine of 12, and it gives me that value. Does that seem reasonable for that length? Okay. So that means I'm going to take that value now and multiply it by the sine of 47 degrees. So times sine of 47 degrees. Okay. And I got to divide it by sine of 90 degrees. By the way, what's the sine of 90 degrees? 1. So that means that the height of that, the height here should be 1815.86. So that's 1815.86. But he's 2 meters off the ground, so that means it should be 1817.86. That should be the height of the mountain. Did I get it right? And when I look at this, I get 1816, and away we go. Now, what did they solve for? They solved for C, didn't they? They got that distance over there. Well, that wouldn't have mattered, would have it? Because by solving for that one, we got 35 degrees, we got the height, we still got 90 degrees over here. It still works out to be exactly the same thing. Again, it all depends upon what you see and how you set it up. So I am going to let you get to work on this stuff, and it should be due at the end of class tomorrow.